Hello Internet, welcome back to DataCube. In this video we are going to be actually making things do a little bit more than they were right now. I've actually already done a little bit of code, you can probably see it all over me. So I have some extra code here. I've been kind of just updating how the LEDs work. So here, we're actually slowly stepping back. No, not here. Sorry, wrong part. Bad start. It's fine. So initially what I'm doing is I'm actually clearing out the entire data set. If anything goes wrong and it starts just filling everything up, eventually the entire thing just crashes, and that is bad. So the issue is this strip actually will preserve that data. So if I actually disconnect the Arduino, I can actually do that now. You'll see the lights stop moving, but they're still on. They're still where they were. So what we need to do is actually clear them out so that if it does fill up and starts it doesn't get into an endless loop and just keep crashing over and over and over again, because that's not gonna work for anybody. So that's what that is doing. Here we have another function that's drawing a pixel. So it takes an index where you want to draw the pixel, and then it takes a color, and then it actually exponentially fades it. So it divides the color by a half each time over 10 steps, which there's only 8 possible steps, because each color only goes up to 256, which is 8 bits, 2 to the 8th actually. So division by 2 10 times, you're already at 0. So it just kind of fades it all the way out, and you can kind of see that here. Well, you may not be able to, but it does actually slowly fade from the pixels. So it gives it kind of that cool trail effect. Then all we do is draw, and then to make them kind of step down like they're doing, I actually have a start that I increment, and it just goes between 0 to 9 and then loops around, and it loops with this modulus here. So this mod 10 is just saying if it's 10, take the remainder of it. So once it hits 10, the remainder of 10 divided by 10 is just 0. So we get 0 again, and it just starts all over. So actually, it looks like they're going down the strip, but physically each of these is actually moving 10 pixels, and then just moving back to its original position. It just doesn't look like that because they all connect. So that's where we are right now. What we need to do, the last thing we need to do to actually finish this part of the project, is accept communication from somewhere else. So what we need to do is there is a serial communication port, or we need to set up a serial communication, which is effectively, you can transfer data over USB. You've done it probably hundreds of times when you send pictures or music or whatever. In order to do something like that, we need to use a serial port and effectively give it the bytes to send or read. So it's actually very similar to a terminal. We're just going to be sending integers from some external server. I'm going to be using a Raspberry Pi, and we're going to be picking them up on this Arduino and then adding them as pixels to draw here. So the idea is we'll send over 3 ints, which will represent the color to draw. We could actually probably use bytes, but I'm going to use ints just because that way we can type them easily. And then we'll send them across, we'll get them here, insert them at the front, and then this code here, all it's going to do is take that data, put it at the front of the list, and then just step it down the entire thing. So we're probably I'm thinking we're gonna stick it into a array and just step down like that. So this is, I didn't mention this in the first video, but Arduinos are just running on C code. So this is all straight C. So you can do anything you could do in C, more or less. One of the issues is there's significant memory constraints. This entire program is using 20% of the entire memory for the program on the chip already, and it's not very long. So there's some work to do there. This is kind of distracting. There's the light right here is reflecting off of my glasses, and I keep seeing blue. But anyway, what we need to do is I have this color structure which just stores the red, green, and blue value. It just gives us something to kind of concretely handle our data instead of individually handling each LED or each color, and kind of we can group them. So I think the best idea is going to be to create a color array of our colors. So what I'm thinking is this is always going to be equal to the length of this. So it'll be a color equal to the number of LEDs, which I don't know if that's correct. It's been a very long time since I have written C code, so this is probably going to be a bit rough, but we're going to get there. Yeah, that makes more sense. I forget, does it? Expect primary be what? Okay, this is awkward. I'm gonna go look up how to do an array and see, because I'm blanking. I know you do that, and then my understanding was you allocate it, but maybe I'm allocating it wrong? Or do I just... That actually might be all I need to do. Hold on. Nope. Okay. Send help. I have forgotten C. That's embarrassing. So, one sec. I'm going to clear this up, and then we're going to actually be productive. That wasn't what I thought was going to go wrong. Okay. Everybody is saying to do it this way. So that's what we're going to do. It's not working for me, so I'm going to pretend like I know what I'm doing. But for this, I'm also going to throw together a really quick function that can actually pitch back one of these structures. So we're going to have return a color that is going to just init color. This is probably not the best name for it, but we're going to do that. And we need this because we were actually like creating colors down here. So we're using it there, but we actually are creating them here. So we need to create colors. Otherwise, this is not going to work. So I'm going to initialize a color, this fancy like Twitter blue, and then we're going to do something else. So color, we need a color. I'll just call it C. C to R, and we'll set that to R. And we'll just initialize each of these, initialize each of them, and then return it. That may cause some issues. I'm sure everything's broken. Oh, no, it worked. Cool. Hey, I'm doing things. Okay, this is one of the other issues I've been running into. This may be like a Windows 10 thing. I am running an insider preview, which causes all sorts of issues. But every so often, the COM port just gets in use and never gets released. So I can't actually deploy, and if I wait, it doesn't actually come back. So I have two USB ports, or USB micro ports for this, and I just have to switch them out of the Arduino. Maybe there's a better solution, but I couldn't find it. Like disabling the device in the device manager, I tried that, didn't work. So this is what we're stuck with. But now all I have to do, go into Tools, rechange the COM port. So we're pointing back to this. It resets it every time because the COM port itself is changing. Every single USB or serial device is going to have a COM port. And since I'm switching between two, those are going to be different. So we need to make sure it's up to date. Then I can do that. You'll notice all the lights stop. That's because it is updating. And then it completes. So everything is good. We're done. Now, what I'm going to do, we have this color array now. The idea I have is we are going to, it's kind of gross, but everything is going to be 0 So it's going to be just blank pixels until a color is there, and then we're just going to kind of march it down this LED until we march it off the array. So if it goes off the array, it's just gone, and then we're good. So that's what I'm going to create here. We need a increment array, increment colors. Let's just say move colors. That's probably a better name for it. So all we're going to do is move colors down. So this actually just needs to be a for loop that starts actually at our final pixel, which will be somewhere. Actually, we don't even need to start. We don't need to start at our final pixel. We can start. So I is going to be equal to, equal to the okay, so I is going to be equal to the number of pixels, the number of LEDs, minus 2. And so the reason we're doing minus 2 is because we're 0 index, so we have to subtract 1. But we also are going to be moving them forward 1, which means we want to move them off the array. So if we start minus 2, that'll be the second to last pixel. It'll be the one right before the last pixel. And then if we move it down the strip, it'll cover up that last one and it'll just go away by itself. So then as long as I is greater than 0, greater than or equal to 0 actually, because if we want to increment that final pixel as well. So then we just want to subtract down I. And so this will just step down our array and move everything down. So colors I plus 1 is going to be equal to our colors I. That's all we're doing. We're just moving things forward 1. And so the last thing we need to do, since we moved everything to the left, we just shifted everything down. That initial pixel, the colors 0, has to be reset because that one wouldn't have been overwritten. So in order to do that, we just need to initialize a color of 0, 0, 0 and just write that into our 0 index. And that should clear everything out. So we've got all of that. That's all good. The only thing that I want to do now is kind of, so I like everything we have here, but what we're doing is incrementing like our start and all of that. I don't like that. We're going to get rid of this. So we're starting from 0 to down the number of pixels down our strip, and we can just increment by 1. So just plus plus there. And then what we want is an if statement. So if the pixel, so if colors 0, or colors I, sorry, is not, or .r is not 0, or colors I.g is not 0, or colors I.b. So if one of these is not 0, then we want to draw the pixel at that position. And we're going to draw colors I. We're going to draw whatever color is there at that pixel. And so since we are, we may need to go backwards on this because we do draw the trail. The trail may actually override some of these, which we can fix later, but for now, I'm going to leave that. So to do invert. So this is going to do it. This is going to draw those colors. The only other thing we want is we want to actually move our colors. So this will actually move things down our list. And what else do we want? The only other thing I can think of is we actually need to put something into our array. So I'm just going to start it at 0. So color 0 init color. and we're just going to initialize just straight red, so 0, 0. And so this should step red. A single red streak should go down our strip and then walk off, assuming I'm thinking of this right. So let's just validate that this compiles. It does. So let's push it to our Arduino, switch out again. This is the most tedious part. And so now we have all of that. It's all good. Upload it. It's going to restart soon. Oh, no, it's not. Port. Switch back. We have to wait for this to fail. Unfortunately, there's no cancel on the upload. So it's going to stop. And we should go. And this may happen quick because it's only going to happen once. Or not at all. So there is a reset button. Okay. I think we broke something. Well, I broke something. So this isn't working clearly. We're initializing this. This should be clearing out the strip, and it's not. Actually, it might be. Because the one thing we don't do is show. So there's a strip.show, I want to say. I'm actually forgetting what it is, but we had it and I must have lost it somewhere. So I'm going to stick that in like so. And that should force it to draw. I don't know why it wasn't. There we go. So we get a single streak that'll go down, and it should go across the entire thing. So it'll just kind of crawl around, and then it will go off. So that's part of what we wanted. That's sort of where we wanted to be. But now I want to be able to send serial commands, because the Arduinos, they're fairly lightweight, and this is already using a decent amount of memory already. But also, we can't like multi-thread this, so if I start trying to do like web stuff or communication stuff, we're going to run into issues, and we're actually going to have some of that in this still. But what we need, we need a way so that we can have some sort of server that's connecting to YouTube or to Twitter or to any other data source, and can actually send data to this, because our Arduino is not going to be able to handle that. And even if it could, it would probably just become a mess. So I'm going to connect a Raspberry Pi to that. I already kind of talked about this. But we need to communicate over a serial port, which means we're sending 3 ints of the color. And so this here is effectively what we need to add, but for serial ports. So we need to initialize a serial port and then start sending data. So the way a serial port works is there is some specific number of bits that is sent over that port per second. So like a default one is like 9,600, and that's called the baud rate, or bits per second. I don't know where baud comes from, but it's just used everywhere. I actually don't even know what it stands for. It's very important that that matches. So what you're sending and what's receiving it have to have the same rate. Otherwise, everything's going to get out of sync. So think of it kind of like there's this flow of data. It's sort of like a sine wave of various points. And so where you're sampling at is really going to determine what you actually see. So if you're sampling at the frequency of that sine wave, you may only get like 0.0000000, even though it's doing a sine wave, because you're only sampling at those middle points. So it's you have to kind of figure out where you're sampling and how you're sampling to kind of get things working. So we need to set all that up. And I totally forgot how to do that. So I've pulled up a ton of things. We're going to actually need this available script because, like I said, there's no threading, so we can't actually have like a separate thread listening for incoming data. We have to do all of that in a single thread because threads are usually handled by your operating system, and we don't really have one of those. So we have to kind of make things up. Okay, battery died. Well, battery didn't die. Camera overheated. My bad. I need to figure out something to keep it from doing that, because it's becoming a problem, and when the summer comes around, it's going to become more of a problem. So I'll work on that. I'll see if I can come up with some sort of solution. Maybe I can do like some massive heatsink or something, like one of my old CPU coolers. That'd be interesting. That'd ruin my camera. But anyway, we need to set up a serial port. So there's really two things we need. We need the serial.begin, which is easy enough. Done. And then we just need to actually read things. So how this is going to work is we move all of our colors, and then what I'm going to do is check if we have 12 bytes available. So every integer is going to be 4 bytes. So what I'm looking for is 3 integers, so I need 3 times 4, and then all we need to do is read ints. Okay, don't actually remember how to do that. This was supposed to be part of the easy bit. Oh well. So parse int. So we're going to give it a integer, and it's going to return a long. That may not work for us, but we're going to try it. So we're going to parse int. So we give it this, and it gives us something back. Why was it saying there was a parse function? Anyway, doesn't matter. We're going to go back here. I'll pull that back up. And we're going to read red, green, and blue off of there. So keep in mind, we just moved all of our colors. So we know there's nothing at that 0 position. And we're only going to read once per time. So we're only going to check for one piece of data. If we send a bunch of them, they'll just queue up. So we're going to parse 3 of them. And then we are going to do something. Stick our colors into there. So colors equals init color. Red, green, blue. There we go. So we can initialize our color, put it in, and it's all good. That should be fine. One of the other things I noticed, code didn't work exactly right. Right around here-ish, you can see it ran off, but then it didn't clear out all of the other pixels. That's a problem. We need to figure that out. And so the way I'm going to solve that is gross. But I'm actually just going to increment this by 10. So -2 plus 10. So 10 is the total fade distance we have. So, well, this is super gross, but effectively what we're doing is we're stepping 10 off of our array, so it should automatically clear that up. So we'll get 1 red pixel, and that'll just sort of be our we've initialized. Let me stick a few more colors in there just so we have sort of an obvious started up look, and then we can move on from there. Did I delete it? Don't tell me I deleted it. I kind of wanted it. Okay. I may have destroyed everything. That's fine. So we're going to set our colors 0 equal to our init color of red 25500, and then we'll also do another one equal to our num, or our n LEDs divided by 3, so a third of the way, and then we're going to do green, and we'll do the same thing, but we'll divide by 3 and then multiply by 2. So we're just doing thirds here. So a third and then 2/3, and we'll do blue. So red, green, and blue should kind of go down this. And hopefully that kind of makes it obvious that it restarted, and we don't lose anything. But other than that, this should accept things. The issue is these parse ints, those are blocking calls. So if we take out this if available, the serial.available, we'll just sit here and wait until we get data, which doesn't really work very well if we're trying to real-time update these LEDs. So that's why we're waiting for the information to get there, and then we're actually going to go do something with it. So there's two things I can do. I can start this-ish. Why is it saying... Oh, so it returns the total number of available. So we want to say if it's greater than or equal to 12. So it returns the total number of available bytes. Let me actually check that. Stream.available. The number of bytes available to read. So 4 times 3, good. So that should be good. Was there something else that was throwing an error? No, I think that's it. So let's try this again. Swap this out. And we get our red. That's just from restarting our Arduino because we just gave it more power. So that isn't actually our new program, that's our old one. So I should be able to upload it now. And we should get red, green, and blue going down it. And we do. Cool. So that's neat. We still didn't clear off up here. I was pointing with my mouse on my recording because I'm looking over here because I have my recording up and I can actually see what's going on when I can't actually see. So yeah, something's still up here. I don't know what's causing that. Actually, yes, I do. Number of pixels plus 10. We're not counting all the way up to where we need to go. So this should solve it. This is gross. Ignore that code. That code is gross. But yeah, so the blue ran off, and the green went off. So they're actually fading away now. So it works. Yay. Final check. And hopefully this one actually works. There's a serial monitor. And so we can input and print things. So what I can do, or should be able to do, is do 25500, send 3 ints, and it should go and be read. I don't see it. I don't see it. Okay, that may not have worked. And I don't know why. So we are going to add some debugging. Part of the issue with all of this stuff, it's on a computer chip. So how do we debug this? We can actually go backwards. We can actually print things back. That's not very helpful. None of these are going to be what I want. So never mind that. That wasn't particularly useful. But we can actually write things. That's not helpful either. Let's find a more helpful example. So one of the cool things is this Arduino IDE, I guess. It includes a bunch of somewhat helpful example code snippet things. They're all fairly basic, and some of them are better than others. But if you can find what you're looking for, it tends to be kind of handy. I think it's under serial, but I'm missing something. Serial call response? Maybe? Don't do that. Dang it. I hate that feature. It's the most annoying thing ever. So we can read and we can write. There we go. Print. Duh. So we're going to write back three things. We're going to do parsed value. That is expecting it to be a character. We definitely don't want a character. Parsed value, like so. And I'm just going to actually push this, because why not? So those will all start going. Can open this. And let's just start sending data. What does that look like? Nothing? What if I just send a bunch of stuff? It apparently crashes. Oops. Not totally sure what's going on here. Because I've worked with serial ports before. I actually did a bunch of cool stuff with it. I had like a Unity plugin that I was passing serial data to something to simulate a vehicle, which was cool. So I had like a simulation of a vehicle, and then I had something that was actually from a car, and it was actually displaying, or it was actually reading out the information from the car, and I was actually taking the simulation in Unity and passing that out so you could actually see real data. And all of that's serial port stuff. But clearly, we're having issues here. Let me kill this with fire. Or just start another one. Nope. No, it's totally dead. Okay. Give me 1 second. I need to restart all of this. Yeah, it's totally dead. Okay, we're back. And we have this. I'm just going to redeploy this just to... because I can. Actually, we don't need to do that. I didn't need to do that. I could have just reset it. But anyway, that's there. What I want to do now is open up this serial thing and try this again. So, like I said, baud rate, those have to match. 9600 and 9600. Those are both the same. So we should be able to send things to this, but I don't get why. I don't understand why it's not working. So what if we do... This may be a really bad idea, but I'm going to do it anyway, just to see what we're actually getting. So this is actually going to output the total number of available bytes every single loop. 3. Lots of 3s. Wait a second. Oh, don't tell me it does that. Still 3. No, I didn't crash it again. What the heck? Okay. I think I want something better than this. This keeps breaking everything, and it's really annoying and not really working. So I'm gonna go get a better serial monitor that can actually handle this stuff a little bit better. But what's happening that I can tell is we're kicking out the total number of bytes, but it seems that... Why was it 3? I don't know why it's 3. Unless each of these, unless it's representing every character as a single byte. If that's the case, this becomes a little bit more difficult, and we're going to need to manipulate things a little bit more. But I'm going to kill this again, get a better terminal, and then I think what we need to do is instead of 12, we're going to expect 9. Not 9, 11. So 11 because we're going to have three digits, a space, 3 digits, and a space, and then 3 digits. So that's a total of 11 characters. And that should do it. And then we just need to make sure every single time, all of our characters are 0, or all of our characters are 3 bytes. That's the best I can think of. Okay, so this is CoolTerm. It's the same thing. It's just got a little bit of more features. And if it crashes, I can just restart it, and I don't have to go and restart all of the Arduino stuff. So hopefully it's a little bit more consistent. I've used it in the past, and it's worked fairly well. So we're gonna hope it continues to do that. So what we have now is a bunch of crappy stuff. This stuff, not too concerned about. What we need is we need to update this thing. So we're talking about 11 bytes. And that means everything has to be a total of 3 characters. Our digits have to be 3 characters, or this isn't going to work. Which is nitpicky, but it's sort of just a requirement of what we're doing. I think I can leave this on because I don't think CoolTerm is going to care too much about that. But I am going to make it a separate line. And that should just make everything a little bit nicer. Okay. Yeah, I'm going to hope this is good. So I'm going to push this out, and then we're going to connect. And maybe it works. Switch these. There we go. So I need to connect our port, upload the new patch thing. It's going to restart, do its little I'm back thing. Attempting to open the port, access denied. Okay, one sec. I'm going to have to sudo this. Okay, this should work. What? Access denied? How? How does... what? Oh. Okay. Sorry. It's been a while. So first off, you have to set up what port you're connecting to. COM4, baud rate. There's a bunch of other stuff. Bit parity, data bits, things like that. We don't care about any of that. We just care about the baud rate, the bits per second. Has to match what we configured. And our port. That also has to be the same. So now that that's good, we should be able to connect. And we're just going to keep getting zeros. So, to do this, 255, enter. No, that doesn't seem to work. Oh, what the heck? Why is it still stuck at 1? So what I don't understand is why this is stuck at 1 bit. Or 1 byte. That actually doesn't make sense to me. Okay. We're commenting that out because I don't trust it. Dang it. Switch again. Which means I have to reconfigure this. That's wrong. Rescan, get COM6. Cool. What? What is going on? Oh, duh. Disconnect it. Upload the new program. Duh. That would probably fix the problem. Then we'll connect here. Nothing should happen. I should be able to just pass over all the information. I don't have a port selected because I didn't select the port there. This was supposed to go so smoothly, but it is not. I'm sorry for that, but That's just the way this stuff goes, especially when I haven't done it. I've done something ish, kind of, not really like this. I've used a serial port before. That's not similar, I guess. But I'm getting weird weird issues, and I don't know why. So I'm gonna connect now. All of those should be empty. So I should be able to go 255, 0, 255, 0, 255. And it should go. 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 No? Better idea. Different idea. Not necessarily better. But while serial.available is greater than or equal to, or just greater than 0. So this is C++ or C, so anything not 0 is true. So we can just do while available. We're going to grab something, and we're going to grab a byte. So we're going to do a serial.byte. This is going to get very gross because we're going to actually have to figure out what the encoding for each of these is, the ASCII for these, which isn't going to be nice. I'm not going to pretend like that's going to be nice. So while it's there, we're going to read it. I'm going to want to split this off into a function, but we'll do that later. So byte, this is going to need to be persisted because it may not fill up totally in this one read. Okay, so we're going to read our byte. So we're going to just take info equals our serial.read, and then we're going to stick it into our generated color index is going to be the index, and we're going to actually increment that. And then what are we going to do? Increment that and set everything equal to our info. There we go. So effectively, we're just going to build a color. And if our generated color is greater than 0, or sorry, our generated color index is greater than or equal to 3, which means we have more than enough data to build a color. Then what we want is we want to build our color. Oh, this is gross. So for that, we're going to just initialize a color of colors 0 equal to init color. Yeah, this is gross, but whatever. Generated color 0, generated color 1, and generated color 2. So this should pull it in. I believe bytes and ints can be converted between one another. If they can't, this is going to break, but I'm going to pretend like this is going to work until it doesn't, which is probably going to be pretty soon. So once we do that, we can actually break out of this. And the reason we're doing that is because we've already created a color. If there's a bunch of data in there, we'll actually just start breaking things if we do that. So what else do we want? Let's print out parsed full color. And that'll just notify us that we've actually parsed something. It's weird, I know. So I can actually drop all of that. I'm just going to comment it out for now. I'm not going to delete this until I know this works because I'm questioning myself. So we're going to have a generated color array, which is going to be an array of 3. And it's going to store bytes. So we're going to have a 3-byte array. And when this happens, actually, we want our generated color index to be 0. So we need to reset that, otherwise we're gonna go out of bounds and everything's gonna break anyway. So we're gonna have generate color index, initialize it to 0 initially. So the 0 is gonna be at red, 1 is green, 2 is blue. And then we'll get greater than or equal to 3, which means we've gone too far. So we have a full color, parse it, add it, break, do everything else. So what this should do is this should take, as data comes in, it should start building a color until we don't have any more data, and then we should be good, I think. One way to find out, that's not going to work. So it might actually be because I just connected a serial watcher. Nope. Okay. Too much crap. So, why does it still think there's something on COM6? That's weird. Connect, publish, and we should get our initialization logic. Should do red and all that fun stuff. I need to rescan here, get COM4, connect. Did you do your thing? No. Which means it's trying to read data and it shouldn't be. Dang it, this is what I was trying to avoid. Why is it stuck? So the issue is we're stuck here. We apparently had available equal to something, saw that, got into this loop, and started reading and never got to the end. But this should time out. So what's going on? Yeah, this is kind of weird. Not sure. Let's see here. Available returns the total number of available bytes. So we know something's available if that's true. And then read. A 0 means no valid data was found. We don't need that. What does read do? Tell me it does something interesting. Reads characters from an incoming buffer stream to the buffer. Or -1 if no data is available. So we should account for that. Oops, this is wrong. So if info is equal to -1, then we want to continue, which should check this. We should have already read it, and everything should be good. I'm guessing in the dark here. This is unfortunate. I was kind of hoping this would be a little bit easier than it has been. It's part of the issue for me is these kind of communication things. There's nothing to watch there's no easy way to watch the wire and visually see what's going on. You kind of have to poke it and prod it until something works or something doesn't work. So it's a little bit more tedious. So this is gonna go on a little bit longer than I had hoped, which is unfortunate, but okay. So that should have pushed. Still not getting anything. That's so weird. If we're in here, let's actually print line the number of available bytes. Because if we get in here, I want to know what's where. So let's do that one more time. Push it there. I'm going to need to rescan and connect. 1. There's 1 available bytes. Why? And if there is, why isn't read reading it? Am I not passing the right things to this? An instance of a class that inherits from stream. Okay. We had open an example where we were reading. Oh, is it going to return like -1 or something? Uh-oh. Okay, so let's do greater than 0. Maybe that was our issue. Okay. Let's flip this out again. That is cool term complaining because I just disconnected its connection. We should be able to connect here. Publish. Cool. That's going. See report error. Got it. Clear. Options. Let's rescan. Connect on COM4. Connect. Things look better. Did it actually do anything? I can't. Parse to full color. Okay. We do actually. Can you see that? Maybe. Okay, so there's a single yellow pixel. Right. You can't see that. I don't know why it's there, but it is, which leads me to believe that things are moving very slowly, but they're not actually moving. So, I'm doing something very wrong. I'm going to disconnect for just a second. And so what I'm going to do is do a serial print line. So we're printing if there's something available, if we're reading something. Otherwise, no more data. Battery dead. Okay, great. All right, so this time my battery actually did die. Oops. I think everything that's gone wrong has gone wrong. Okay, better focus. There we go. So, I don't know if you can see that, but I have this weird blinky majiggy going on. And it's very, very light, like white. And it's every third pixel is the one blinking, which is why it looks a little bit stuttery. The way I got there, shortly after the camera died, figures, what I was doing is I was replacing all of our integers with what the library is actually expecting, which isn't an integer. It's actually a uint8, which is an unsigned 8-bit integer, which is effectively just a byte that isn't signed, which makes sense. So I replaced every reference to that, like our color is now using uints, our init color is now using uint8s, etc. And so that got me here, which is a little bit funky, and I'm not sure where that's coming from, but I'm going to pretend like it makes sense. We're going to get rid of that. I'm just going to say if it's greater than 32. I don't think that makes any sense, but we're going to do that anyway. So I'm going to kick this off, send it over to our Arduino. That should get rid of those. And it did. So now we have those three colors sweeping around. I'm going to connect over here. And I can now send data by just sending 3 characters. I also removed a lot of the prints, mostly because they were slowing things down, I think. So right now I'm just sending white because I'm hitting the same character 3 times, but I can send any character I want. So that's like a pinkish, sort of like a green, and we can kind of play around with this. do whatever we want. Oops, blue. More white. Yeah, so not really relevant what colors we're sending. I'm mostly just poking at this, trying to see what I can do. But short story, I guess, it works. I guess read the documentation is probably the advice I'd take from this, because we shouldn't have spent all that time on this without reading the documentation. We also probably, so I'm capping it so values less than 32 are ignored. The reason I'm doing that is simply so that, actually that's not going to work. Because that way we can't do like pure red. So greater than or equal to 0. Sure. Let's try that. I think there was something that was causing us to keep getting whites. So hopefully this fixes it. Can't connect. Access denied. Why is that? Well, that's inconvenient, because now I can't test it. Blarg. Okay. Now we're just sending random data. Where'd that come from? The heck? Okay, that was weird, but yeah, so there's just random stuff happening now. I'm not doing that. Where is that coming from? I honestly have no idea. It's ghost code. I have no idea. I'm gonna try to restart this because I need to actually be able to send stuff. So that will do that. We can connect. There we go. And now we can send actual stuff. So I can actually just keep pressing things. That probably doesn't sound great, but we can actually send quite a bit. Yeah, actually, since we have this while loop here, we could theoretically send a new color every single frame. I don't expect we're ever going to have that kind of traffic where that's going to become a thing we do, because that is a lot. But yeah, it actually works. So it took us a while to get there, a long while, but it does things, and that's the best kind of software, right? So I guess since it does do things, that's good. I'm struggling with words, but that's okay. Next thing I think is we're going to actually, so we're going to leave the Raspberry Pi out of it for now, but I'm going to drop this cool term, and instead we're going to have some sort of server that's going to serve random data down this. So like basic MVP is literally just a thread that just kicks off new data constantly, and that would work. It's not clean, it's not good, it's not anything really, but it's simple and it would work. So we'll probably start there and then probably make it more advanced. We might actually just pull in our Datasphere Twitter integration, because that already works, and that way we can just follow a hashtag and see what happens. So that's next episode. So see you then, I guess. Yeah, if there's anything you guys, any feedback you guys have, or anything you want me to change or do better, like fix my camera, I actually do have, I haven't plugged it in because I don't know how well it's going to work, but I do have a battery that should somewhat help with the heating, but also should help with running out of battery. That battery. So what we're going to do is I'm gonna be testing that out this weekend and then see what happens. I'm gonna ignore the fact that my camera just died, and that it's backwards and all of that, because we're done. But yeah, it so hopefully that fixes a lot of issues, because it's becoming annoying, and especially with live streams, I don't know how this doesn't work with live streams. So we need a better solution. So I'm hoping I found it. If there's anything else you guys want, though, leave an idea in the comments, or let me know what I should change or do differently, or call me an idiot for using the wrong data type and breaking everything. That's perfectly valid. Yeah, that's about it. So until next time, see you, Internet.